Now I can speak softly. I tend to write sessions that I want to go to. Because, there's stuff I'd like, there's things you want to know. And so when I can't find the session to go to, I end up writing it. This is one of those sessions. I've been doing performance tuning for a really long time. My name's Richard Campbell. I laid my hands on a microcomputer in 1977. It was a TRS-80 Model 1. It had 4K of RAM and a cassette tape player and 3 error messages. What, how, and sorry. Which, is probably the most descriptive error messages I've ever seen. Because really, when you see object not found, all I think is, sorry. It's been been a geek for a really long time. I look younger than I am. I have a 20-year-old daughter. My baby just turned 16 yesterday. I've always enjoyed the scaling problems. I scaled DCOM, and if you've ever done that, you know the D stands for dumb. But these days, of course, when you talk about scale, you talk about websites, right? That's the thing that most people care about scaling up. But there's lots of other technologies. I've scaled up WCF solutions. There's all kinds of things of, how do you make it go faster? It's for me the most interesting work because I sort of live in two worlds. I'm as much an IT guy as I am a dev. I do both. And if you're going to be good at making things go faster, you have to deal with the operations side as well as the code. And I also found that sitting in the middle between those two things pays more too. So I picked the, if you're going to, I only want to work so many hours, I might work the hours that make the most money. So I ended up there. Now, Strange Loop Networks is a company we started back in 2004. It was a research project. It was this idea of, can you automate scaling? Can you build a device that would actually make websites go faster? And it took us about 18 months to prove that we could. And we filed a patent in 2006, raised a whole big pile of money, and we've been spending it ever since. So we make an appliance that makes websites go faster. And a lot of the data I've got today comes from the work we did at Strange Loop, right? It's still going on. We're on just about ship version 5 of the appliance. We don't have a booth here this year. We tend to be going to e-commerce shows these days because we're now at a place where we're totally focused on ROI, and so different audiences. I'm also, any .NET Rocks listeners in the room? A couple of, all right. So .NET Rocks is a podcast started by my good friend Carl Franklin back in 2002. I came on board on show 100. We are now on show 662. So we're thinking about what we'll do for show 1000. It's about an hour-long interview with a .NET luminary. We do 2 a week, Tuesdays and Thursdays. We're recording a few here as well, and we're doing Speaker Idle and 64-bit question, a bunch of other silliness. I exercise the other half of my brain with Run As Radio. So this is an IT-oriented podcast. It's about a half an hour. We do it once a week. We're at about 210 episodes now. And very different flavor. But it's just, I live in both worlds. And I'd love for you guys to listen to the show. They're free. Happy to, we sell advertising on them. That's how we pay for them. And it's a good fun for me to constantly be talking to people about what's next, how technology works, how can we make this thing better. It's a constant process, and it's one of my favorite things to do. But the scaling work is just interesting, hard problems, day in, day out. And so this session was really, everyone tells me that performance is important. Everybody wants their website to go faster, but I've had customers where we doubled the speed of the website. We took your page from 10 seconds to 5 seconds, and the guy said, so what? Big deal, right? Why does that matter? Why do we care if the page goes fast? So what I've done in this session is rounded up a lot of data around those things. And I'm going to talk about big companies and some small companies, and we'll talk in detail about where this goes. So why does web performance matter? The simple answer is big piles of money, okay? That's all, big piles of money. Now, different websites have different ways that they affect money one way or the other. Most websites, there's more money out there than you can grab. We're limited. We've got this bottleneck that limits the rate that we can bring money in. Now, it's fine when we talk about e-commerce sites, but there are other elements to this, and the way we can generate revenue. So let's go through sort of the iteration. I want to set some terms in place because I'm going to use these terms over and over again as we start looking at the numbers, the results that these companies have got. So it starts with, how do we get a lead, this sort of first touch? lot of times, especially when we're talking public-facing websites, it's search, right? Search is the thing. They're looking for ladders, and you have a ladder website. And so that they find you by search, they find you by tweet, they find you by some particular mean. And that turns into your initial visits, right? First hit on the website typically goes to a landing page, right? The home page of some kind. Maybe you might have more than one landing page, depends on the kind of site. And we know from experience that there's a bounce rate. There's a non-trivial number, depending on the site, as high as 80, 90%. That's it. People leave. This was not the site for me. Google has failed me again, right? And an ineffective search. But a certain percentage are going to stick. Right? That's our new visitors, and we're getting new traffic off of that, and now we've got an opportunity to do something about that. Now, bounce rate's an important topic here because faster sites have lower bounce rates, plain and simple. Right? And the math, the data shows this over and over and over again. So now, next stage, if we've gotten past the bounce and you're actually a visitor, how many pages do you go to? What's the flow? Right? We follow a flow from the landing page. You know, maybe it's Amazon.com, and you search for a book, you look at the book, you buy the book, or you stick it in your cart, or you don't. You look for another book. There's a flow to that, and one of the measurements we can use to show that we're being productive, that our site's working well, is how long did they spend on the site? How many pages did they go to? So more time ultimately can be more money, more results. The longer they spend there, the better they hopefully like it. You know, one would say if the site's slow enough, they will spend more time. But it's not really, doesn't really work like that. And so we've got your attention phase here where we got the initial contact, engagement, where we got past that bounce, got some page views, we spent some time on the site, and now we get into the metric, the KPI for your business. What matters to you? Now that might be search impact. So you have a site that is driven by search traffic itself, right? Think of a place like About.com, right? They don't really sell anything directly, but people looking for stuff on their site is ultimately the way they make money by serving up appropriate ads. Search for them is what matters. Ad clicks. You make your money from advertising, and so the more time they spend on the site, and the more pages they look at, the more likely they are to click on ads, more money for you. If you're dealing with an internal site, right, or a vendor-related site, an extranet site, it might be just user productivity. Faster sites mean a given person can enter more data in a given length of time, or that they're happier using it. A site that delights. What a concept, right? That our users would actually be delighted. I just love filling in my timesheets. It's the best thing ever because it's a beautiful site. I mean, I really feel that way about this WinPhone 7. Like, it's a delight. If you have played with Metro, it's a delightful interface. It encourages you. It makes you want to look at it more, right? And lots of folks have that reaction to the iPhone. And there are great websites. And one of the things you'll see over and over again that's the key to that is that responsiveness. Speed matters for delight. Finally, we can't ignore if you're running an e-commerce site, you care about conversion rate. For anybody who gets past my bounce and actually visits my site, how many of them convert? They buy. And how much do they buy? And so the question is, as we get into these kinds of numbers, does a faster site increase these metrics in a relevant way? Now, there's another element to performance tuning. There's two things really to be concerned about when you do performance tuning. The first is this: performance costs money, and it's like air. You don't care about it if you have it, right? Nobody cares about the air in this room right now, but if I took it all out, you would care, all right? Performance is exactly like that. When you have it, it motivates not at all. It's only when you don't have it. And the perceived value of that performance is when it's missing. The effort to create performance, to make sites go faster, goes away from optimal development. The presumption is we build the site the optimal way today. Okay? Mainly being we're using the skills that we have. We know how to work this particular way. ASP.NET is very good at building sites fast. The question is ASP.NET very good at building fast sites? They're not the same thing. The default techniques that work like a hot damn in ASP.NET are typically quick to build the site, but not necessarily the fastest running site you can make. And the process of re-engineering that site into the fast version, A, it takes time, so it costs money right up front, but B, it impairs all development that goes beyond it, right? It's now harder to build features because of performance tuning. So it is not free. Performance tuning isn't free. It costs money, and you have to account for that. The question is, do you get sufficient return? So as our pages get faster, and that line, we go down that line, costs go up. And there's a sort of happy medium, and we've got to debate how fast do you need to be for that to actually make sense. So it's easy to make a slow page, hard to make a fast page, and it costs more. And there is no perfect ideal. There's lots of research that's been done to say what the perfect speed of a web page is. So this is the Zona Market Bulletin report. And all the numbers I'm using here, I have references for them all. So if you want to dig into this, one of the things we've done at StrangeLoop on our website is gathered together every bit of performance research we could find, because we couldn't find a good site for it, so we figured we might as well do one ourselves. So this is one of literally hundreds of white papers we've pulled together. It's from 2001. It's old. It's wrong. It said that web pages need to be no slower than 8 seconds. That 8 seconds is the patience threshold. And then they came up with all these other ideas around tenacity and importance. You know, the difference between shopping for cotton candy and filling in your TPS reports, right? Stuff you must do to be paid versus stuff you want to do, you know, decreases tenacity. But this is from 2001, when the internet just wasn't that fast, right? We were still dialing up, and broadband was relatively rare. More recently, Forrester, this is 2009, did a report around e-commerce that said the perfect number is 2 seconds. That if you can get a page under 2 seconds, that's the maximum happiness you can get. I've recently seen stuff out of Google that says the ideal speed is 100 milliseconds, right? So as long as you don't communicate over the internet, it should work great. So that, a little too fast. So I want to run through a few different projects. Lots of organizations have proven that speed matters, and one of them is Microsoft. So the Bing guys did a very clever thing. They've done all this stuff to make their search super fast, and the big debate was, did it matter? So they did the thing called the slowdown experiments. They actually made Bing run slower. And this is the resulting data. So that's in milliseconds across the bottom. So with 50 milliseconds added decrease in performance, they had no significant impact in any of the metrics. And then all the way to 2 seconds of delay, okay? And there's a bunch of different numbers here. Queries per visitor, query refinements, that is, how many queries did a given person do? When they did a query, did they then change it to try and get more detail? And revenue per visitor, because they actually sell CPM ad space on Bing, so they're making money there as well. Clicks, did they actually click on something? And satisfaction, which was actually a measure, right? They surveyed for, you know, how are you happy with the site? So they slowed down the site by 2 seconds and over 4% less query refinement. Now, out of millions of people, that's a lot, right? This is, you know, 4% revenue drop, that's your fault, is a big deal for your boss, right? It's a measurable, significant number, and that was just slowing it down by 2 seconds. This was not 20 seconds. So that's what Bing did to gather this data. They did it to the whole site and just logged what the effects were. How does the change in behavior work? Very, very big site. Now, a slowdown test is kind of clever, and that's search engine, and, you know, unless you're building a search engine, and if you are, why? It's not going to be all that relevant to you. So let's go to one of the biggest e-commerce examples I can possibly find, which is Shopzilla. So this is a massive e-commerce site, and they did the big battleship move, the one that nobody ever goes for, the let's rewrite everything. They did it. Okay, no fooling kind of number. So this is, you know, like I said, 100 million views a day, 8,000 searches a second. How's that for infrastructure, right? This is a big site. Their re-engineering was over a year. They took their pages down to 1.2 seconds from 6. 6 is pretty good. 1.2 is epically good. But the more amazing thing was they actually increased their uptime. The site's even more reliable, and they threw out 90% of their hardware. Because the site was that much more efficient, they just got rid of a need for a lot of horsepower. So they didn't actually throw it away. They just don't need to buy anything for quite a while. They turned a lot of stuff off. They densified a lot of things. And this graph here is their average page time. So that you can see how much that page time dropped day in, day out. They rarely tip above 2 seconds now. This is all very cool, right? And you can say that interesting savings, but what does it really equate to? Okay, this is a 16-month project. Any guesses what this thing would probably have cost them? $200,000, $300,000, $400,000 worth of work, easy, right? Increased revenue by 5 to 12% in any given day. Pays for itself in a year, right? So this was a big, as worst case scenario I could imagine for a re-engineering of an application. They ripped it apart and redid it. They saved a lot of money on the back end with the equipment they're using, but the bottom line was taking those pages from 6 seconds to 1.2 seconds significantly increased their revenue. And so this paid off, right? The challenge here is you've got to deliver. You've got to get down to that kind of speed to get that kind of result. Totally different kind of project. I mentioned About.com already. So About.com, if you've never been there, this is a site that very much focused on how do I's, lots of information there that's freely available because they care about the searches because the searches are what they sell. They put ads on the site, a lot of information there. Now they did a very different kind of project. They did an IT. How many folks here consider themselves an IT pro? Just a couple hands. And everybody else a developer? How many developers in the room? And the rest of you are just happy to be here. Okay, so mostly developers in the room. So this is interesting from this is very much an IT pro move. Rewrote nothing, reorged everything. Combined all the JavaScript files into one, combined all the CSS files into one, switched over to static content without cookies wherever possible. You started using CDNs. Turned on caching everywhere, right? This is largely configuration in IIS. Lots of setting changes. Used compression. Used PNGs. All of the tips and tricks that guys like Steve Souders and so forth talk about how to make without rewriting the site. Went after the media vendors, the folks that put up those ads and so forth, and said, you need to make me faster. Right? We want this to be better. If the faster we go, the more money we're going to make. So what interests me about this move is the risk of breakage was really low. So that's the thing that I wrestle with when we're doing performance tuning. We're taking a page that works, and we're going to change it. So it's dramatically faster, just wrong. Right? Or the worst one is they forget. You spend 3 months doing performance tuning, and you soup it up, and what does the boss say? Didn't ship any features for 3 months, right? Performance doesn't look like anything once you've got it. So this was really interesting because the risk of breakage was low and the results were significant. 20% performance boost, 19%. So it's not a trivial amount of time, right? You're talking about going from a 10-second page to an 8-second page. Almost a percentage point in increased revenue for a re-engineering job. So and the point I'm trying to make here is you don't have to do the big one, right? There are the little ones. Remember that curve. They stayed high up on the curve of cost. They did not spend a lot, and they did get measurable results. They made more money for setting some configuration settings. It's worth it. Take the time to understand this stuff. Go through. Turn compression on. It's free. Okay. Every site I've talked about so far is like in the top 500 websites in the world, right? I mean, we're talking about Bing, and we're talking about Shopzilla, like these are big, big sites. Auto-Anything, you notice, this is a very nice company, and these guys actually worked with Strangeloop. So another way to do performance tuning is to buy my appliance, right? Now the reality is, there's only a few things inside of the appliance that are just simply black magic, and you wouldn't believe what we do. But the reality is, the bulk of performance tuning for websites looks the same. Stuff like combining your JavaScript files into one and combining your CSS files into one and putting your Google Analytics at the bottom of the page. All of these things, you can even combine all your images into one and rewrite with CSS to sprite out the images, right? Turn your page from 60 round trips into 5 round trips, and it will go faster, right? But it takes time to do all those coding tricks and so forth. And in essence, that's what our appliance does. It does it for you. So this is one of our customers. Like I said, this is where a lot of our research came from. And they were confronted with the very normal issue of, we're busy shipping features. We don't have time to do performance tuning. Will you do it for us? So we did this. And like I said, it's not a small site, but it's not a huge site either. But the result of doing that was taking their landing page went from 14 seconds to 7 seconds. And that's what I like about these numbers. This is a perfectly mortal site. 14 seconds does not fit into any of the Forrester or Amazon guidelines for an optimal site. But it was a completely successful business, as it was. Right? 14 seconds is good enough for a lot of customers, particularly people who buy auto parts. They were happy. We got it down to 7 seconds with this round of performance tuning. So what did we get out of it? Well, the first thing is the size of the order went up. Now, that was interesting. People bought more when the site was faster. And it wasn't 100 milliseconds. It was 7 seconds. It was just faster. More conversions. If you came to my site and you spent time on it, 9% more people actually bought something. But there were cooler numbers than that. The number of buys on the first visit went up massively. A 29% increase in first buys. Because what we were used to was, and we'd watch this with cookies, they come to the site 3 or 4 times before they finally buy. They sort of build up their confidence and they shop around. I mean, that's just sort of the ritual. When you can get a first-time buy, you've done something right. And that jumped, and the only thing that had changed was we made the site twice as fast. We got it up to 7 seconds a page. And more people come back. So you take your sales figures and you think about how much money this is in your business. This is how you shop to your boss for a performance tuning project. Hey, look, these guys took a site from 14 seconds to 7 seconds. And this is the kind of increases they got. I know we're making this much money today. If we can do the same thing, we should be able to get somewhere into this neighborhood. That interesting? I know if we, and I think developers especially, we fall into this trap where we forget how the company actually makes money. Because it's never us, right? We help the people who make the money at the best of times. Sometimes we help the people who help the people who make the money. We're really far removed. And the reality is if we don't benefit the business will survive without us. We probably won't survive without them, right? That's our source of income. So, we've got to remember where our roles are in all of this. So, anybody go to the career talk on Sunday? We were talking. Anybody go to that career talk on Sunday? It was a workshop. And I said this particular line. Somebody was saying, when did your career really take off? And I said, the one thing that happened to me that changed my career utterly was I got really good at calculating ROIs. How much, believe me, we have the best job in the world, okay? Development job, because it's the only place, the only thing you can do where you can literally make an order of magnitude improvement to a business. Right? Where I can take somebody who can currently enter 20 orders and write a good piece of software, and now they can enter 200 orders. Show me anything else that can create that kind of return. And that's the kind of thing we're talking about here. Right? That I don't have to spend more money on marketing. I don't have to do all of these other things to try and increase revenue. I just take the software and build a better version. Now, it's not that it's easy, but that it actually pays. Right? That the cost of your salary and maybe the 3 other guys you're going to work with and the tester and perhaps a consultant, bringing together that expertise and making a project that is $50,000 or $100,000, $150,000 over 3 months or 6 months, you'll pay for it if you can get the results. All right, so I've talked about specific companies. Now I want to talk about some collective research. Anecdotes are cool. We all love them. I love anecdotal stats, and I can do them all day, but they're anecdotal. So what we did was we gathered a bunch of our customers together that were willing to be part of an aggregate. It's very hard to, you realize AutoAnything's performance improvement is a competitive advantage. They do not want to talk. They will not tell me how much more money they're making. They'll only give me percentages, right? They're not going to share those numbers, right? So lots of the companies they're working with, the same boat. They don't want to tell these things, but they were willing to be part of our aggregates to show when we improve performance, what are the kinds of results you get. So we focused on one little area. Doing this kind of research, by the way, is really harder than you think. It makes me crazy. And I'm going to talk about how you can instrument your site to start gathering data like this. So we only focused on landing pages, the start point of a flow. What's the page that you get to from the search engine? What's the page that you advertise? What do you tweet out? Those landing pages. The beginning point that will ultimately lead to a sale. And that's the page that most people, you get bounces off of, right? They go there and they never go anywhere else, right? That's really what a landing page is all about. It's the starting point. And obviously, this has big impact. If your landing page is fast, that's the best shot you've got at not having a bounce, at turning them into a visitor and hopefully converting them. Here's the aggregate numbers. So this was across about 20 different companies. The range from 1 second to 22 seconds. So at 1 second, the bounce rate was whatever the bounce rate was. So say it's 50%. Okay? By the time you've added 5 seconds to the page, slower, you've doubled your bounce rate. Doubled your bounce rate. That's a lot fewer people sticking around because your page took too long to load. It's just the landing page. By the time you add 10 seconds on, it's like 125%. So this gets huge fast. And eventually, the curve tapers off. There are some people who aren't paying attention, and they will wait for your page to load all day. Right? But at this end of the curve, that straight up line between 1 and 5 seconds, that was a shocker to us, that it happens that quickly. As you lose some time, your bounce rate starts to go up dramatically. Pages per visit. So everybody's site is different. Some sites, a successful purchase can be done in 6 page views, right? Beginning to end, done. I know a few that are like 2 or 3. Some sites are 12 or 15 pages. And so if I only get a guy who will only go to 2 or 3 pages, I can't make a sale to that guy, right? I need him to do 10 pages to get to the conversion point. And so as we add time, by 5 seconds, you've lost 30% of the page views, right? Guy used to go to 9, now he's going to 6. And your sale point's probably around 10 to 12, so you've got a problem. Add 10 seconds, you're almost at 50% of fewer pages. We don't count bounces to this thing, right? Take all the ones out when you talk about page views. It's just, you got to separate those two things. So, yeah, at least a second page worth of views. I think we aggregated this over something like 7.5 million different web hits across all these projects to try to pull these numbers together. But yeah, once you get rid of the bounces and they're visiting more than one page, if you add 5 seconds onto the page, you cut the number of page views in half. Conversion rate fall off. So this is actual money. Guys that would have bought, but you waited an extra 5 seconds and 40% of them won't convert. It's just a lot of money. Right? And so this was by aggregating this data together, we saw everybody's points are a little bit different, but when you start combining them, they straighten out into a fairly tight grouping of lines. And you'll see that the fall off of 1 to 5 seconds. So take it the other way around. If I can take 5 seconds off a page, I can get 20% more conversions. Right? Like it's not a trivial number. Right? We can make a big difference for not a huge amount. I don't need you to get to 100 milliseconds. It'd be nice, but it isn't necessary, right? The 2-second rule is a cool rule. There's nothing wrong with it. I mean, I would make the valid point that getting to 1 second is probably not going to get you a lot from 2, but I look at this and say, now getting from 14 to 7, I now know why they got the returns they did. These numbers support AutoAnything's results. And AutoAnything's not actually in this data set. All right. I don't know if you noticed, when I showed you Shopzilla's results and so forth, and there's no common set of graphs. Nobody seems to be able to agree on what good instrumentation is. Right? It's a huge battle. There's Gomez, there's all these different sites that try and simulate the performance of your website. Right? We like webpageloadtest.com. It's a fun site. It tests remotely and so forth. But after doing this for this many years, I'll tell you this, there's only one set of numbers that matter, and it's the production numbers. I've given up trying to simulate the performance of websites. I'll do load testing to determine what the theoretical maximum load of a site is. We'll put together a similar infrastructure what the production site will be. We'll use load testing gear to jack it up and say, we're going to fall over somewhere around here, and that gives us a sense of impending doom. We know when we get this busy, that we're going to have problems. And it's useful when the marketing guys say, hey, our goal is to double traffic on the website. I'm like, excellent, we'll crash. Right? At least you know what your thresholds are. But when I actually talk about performance, we have to do it ourselves. We've done it every time. And it's because every business is different. You know, I'm talking about conversion rates because we're dealing with e-commerce sites, but maybe you care about satisfaction, or you know, you just care about time on page. Your stats, the way you feel about your site being successful, is going to be different from someone else's. And so you need to be able to measure the time, and you also need to measure the real time, not simulated time. You actually need to know how long that took each of those pages to render and get it back to you in some way. So I can't point at a product and say it does a good job. You need real data for this. Sir? At which point did you measure the time? Is it off the server? Is it rendering? An excellent question. What matters is what the user sees. In point of rendering? Yes. It's all about the rendering. How long from the moment he clicked on the link or typed in the URL to the page is viewable. And there's tricks to, you know, make the page show up before it's finished rendering, but the bottom line is that's what matters, which means we must measure it at the browser, which sucks. But we must. That's the user's experience. There is no other way. And so that's this concept of beaconing, that somewhere stashed in the page, we're going to have a chunk of code that'll beacon. Right up here on the aisle. Sir? What? The only way I'm going to be able to measure how fast the client renders on how it renders the client's page is to actually time the page. With what bandwidth on the client side? You're talking about you're going to actually. Yeah. It doesn't matter what the. Yeah. So it's going to be all. Well, there's a funny reality. I do another talk where I have the performance equation where I break down where time is spent in a given response time, and typically the bandwidth, the transfer time, represents 2 or 3% of the total response time. Bandwidth's not usually the issue. Round trips is usually the issue. Question at the back. Well, it's the distraction devices, the spinning wheels, and the progress bars, which you ever found if you make the progress bar back down, it makes them really angry. Yeah, don't do that. Dancing, you know, we do something. Watch this. It doesn't hurt, but ultimately, page render times are page render times, and we've got to set a metric, right? My basic metric when we talk about general browsers is when the onload event fires, right? That's when the DOM says I'm done. Right, I've gotten to the bottom I've hit my HTML tag at the bottom, I'm done. That's on load. And you can trap for that, right? This is a little scrap of JavaScript, and we see it over and over and over again where I grab a timestamp in the header, and then I trap for the onload event, and I take another timestamp, take those 2 times, subtract them, and then I get them back to the server. And that's actually the hardest part of it. You know, writing that chunk of code is not that big a deal. And I want to talk a little bit about HTML5 because it does a far better job of this. But now the back-end part comes into play, which is we've got to send that back. My favorite way of doing it, the beacon approach, is you use a little JavaScript to rewrite a link to an image on a page so that it ends up in the weblog and the timing information is in the query string. So it's just part of the weblog. We can ream through and look for those query strings, and then we can add up the times. We also get what kind of browser it was. You know, there's some useful information there, what the IP address was. We can say, well, that guy's in China. No wonder it took so long. You know, you learn a few things just from taking it off the weblog. So you're just adding a line into the weblog for every page request to grab that thing off. Beacon technology is well known. It has a lousy reputation because it's generally used for spying, right? For tracking people. This is the stuff that DoubleClick and so forth use. We're trying to use it in a relatively useful way to just give us a record of how long that page took. Web timings is a new class as part of HTML5, generally speaking. Every browser out there of the HTML5 variety implements it a little differently. And before I show you this code, let me just flip over. This is the IE9 test site. If you've never poked around with this, this is the navigation timing. And so they actually now have a detailed timing model available. It's part of the HTML5 specification, but all of the implementations of them are unique so far, which makes it really a bear to write code for everyone to use it. But I just wanted to give you a sense that beyond just getting on load, we now have a lot of data available on every Chrome, Firefox, Opera, IE9, they all have this cluster of events available to you. So and the times in milliseconds starting from January 1st, 1970, because what a great number. So you probably want to subtract those before you try and send them back. But you can see this is the IE9 test drive site. So this is their demo of this. It's just a little scrap of code. It's pretty simple to do that. The tricky bit, of course, is that this implementation in IE9 is different from the implementation in Chrome, is different from the implementation in Firefox, is different from the implementation in the iPhone and in WebKit. They're all different. So I included in the slide deck so that you guys can look at it afterwards. This is a chunk of code we've put together basically to try and have a single call that will give us the timing using any HTML5 flavor. Okay, and if none of them actually work, then it just grabs the onload event. So these are actually a couple of functions at the beginning that calculate milliseconds and deal with the fact that IE9 does it its own way. Shocker. The important part here, testing for headers. I don't know if you've ever read this kind of JavaScript before, where it says head equals head or r.pg.head or null. So now I know, can I actually get the header to check? This is where I'm checking to see if this is a cached page, so the timings will be a lie. So I'm avoiding all of that. And then time subtraction. Here's all the chunks of data. So this is what we end up doing. Is if we've got a good nav, start. So we've checked to see, we've used perf equals W performance, which is the supposed HTML standard that nobody's implemented, or .moz performance for Mozilla, or MS performance for Microsoft, or WebKit performance for the WebKit implementations, that's the iPhone and so forth. Then we've got a perf, we can now reference the object, we can tell nav start we want to capture the data, and then there's all the different chunks of data we get. So it's actually really detailed information. We could tell if we've been redirected and how long that took. We could tell when the connection initially started. We're right at the beginning of before they even had anything in the page, it already was collecting the timings. That's what's great about this the browser here. It's more accurate than we can get off of any chunk of JavaScript. Time has already gone by the time the JavaScript arrives at the browser to start grabbing time. So this gives us much more accurate results. But I wanted to show it to you just to say this is possible. You got to do it yourself, and you can have this code. It's in the deck. Download the deck and tinker with it. There's more to it, getting it right. There's the whole server side of things, but you can get very accurate measurements here. And all we do is chain all this together and feed it as a query string back to the log, and then we scrape it out of the log. Couple of things. This is more data than you think. It's a lot of data. It will make your SQL server cry. Or you're going to have to build a honking great SQL server just to collect these stats, which you're not likely to actually get money for. Ask me how I know. And it's expensive, and you don't need to, because in the end you're always doing the same thing with the data, which is basically adding up and saying what's our average page time. That's kind of a waste of a SQL server. So not that I'm a huge NoSQL fan. I'm actually very much a SQL guy, but this is what technologies like Hadoop were made for. Distributed, simple data stores that just allow you to pump reams of data down. The only other thing I'd say is don't push it to the cloud, because you'll find out you pay a lot in bandwidth. You're hauling a lot of data up all the time. Also, the moment you transmit this data to a different site than the one that your page went to initially, you are doing cross-browser scripting, or cross-domain scripting, and most browsers freak out when you do that. And it makes the customer upset, which is another way of decreasing conversions. A couple more things, and I'll take more questions, or we can dig into other elements of this. This is a new talk, and I wanted to leave some room for exploring other ideas. You need to instrument your production application. You need to do it in a way that doesn't impair the performance of your system, but you've got to collect the data. There's no substitute for real data. It's the thing. When you're trying to justify doing web performance tuning, one of the options is the Bing trick. Make the site slower and show the decrease in revenue. You probably won't be able to do that for very long. But it is a way to prove that it matters when you're dealing with folks who don't think it matters, right? And the stakeholder, the boss, is saying, I don't care how fast the website is. It makes enough money now. Well, hey, look, we'll slow it down 5% and notice this decrease in revenue. We added 3 seconds onto this page, and yeah, it cost us 5%. He'll say, take that off. And then you say, but if we get 3 more seconds back, we could make more money and get them on board. So it seems counterintuitive, but the negative approach is easier, faster, and it will actually show up the things you need it to show. And finally, recognize that the performance curve is pretty smooth until you get down under 2 seconds. So for every second you save, you will get return. Right? It's worth it. And again, the main thing to remember is you are not the customer. Our perceptions of websites are so skewed from mortal beings. Okay? We are far more patient, believe it or not, really, as much as we will say this site is slow, but we won't leave. We don't bounce. Right? Because we know how hard this stuff is, we are far more sympathetic to the vagaries of slow websites compared to mortals. Mortals don't know. They just move on. Next. Next site, next site, next site. Right? But watch your grandmother surf. Besides clicking on everything, right? They have no patience. They just walk away. Next site. There's always another website. There's lots of them out there. And so once you see that, you start to get a better appreciation for how we can have a tiny percentage, 10% faster, 2% additional return. It doesn't seem likely, it's counterintuitive, but the numbers pan out. The curve is smooth. It keeps happening. So it's absolutely worth it. A few resources to point you at. This is the standard WebTrack resources. So Scott Hanselman's blog, Scott Guthrie's blog. I added a couple in at the bottom there. So Web Performance Today is my friend and business partner Josh Bixby's blog about web performance. But I think I would argue the last link here from Strange Networks, this is our Web Performance Optimization Hub. The main thing there is we've gathered together everybody's research. It's just a big pile of links. So if you want the Google research on performance, you want the Amazon research on performance, everything we could find on the internet, we put it there. So, and it was originally just a resource for us, but we're just letting other people at it. So if you want to check my numbers, you want to get some additional data to make an argument for performance tuning, this is the best place I know of. That's why we put it together. All right, and you get that picture? I'll wait. We should really make a shorter link, I guess. But. And of course, MyTechEd, if you haven't been there already, these are all great sites. There are a few performance white papers that Microsoft published, not very many. There's only a couple. Maybe I should write some. Don't forget to complete your eval. You'll win an Xbox, maybe. Somebody will. And there's your tag. What's that? The Xbox? Oh, yeah. Well, when you put 10,000 geeks in the same building, have you noticed the 3G for Atlanta, downtown, is really struggling? Everybody's got a high-speed phone. Like, this is great. We're a great stress test. We should be charging out for this. Hey, you want us to mess up your city network? We're here for you. I've done my slides, and if you want to go, feel free to go. There's one thing, some folks asked me earlier about the whole discussion around 32-bit operating systems versus 64-bit operating systems for websites. So this is getting into, I could talk about the numbers and a nice high-level stuff, but I actually do this stuff too. The issue, and so the most common web server I see today, the Pizza Box, is a 2-core, 4 gigs of RAM, 32-bit OS, right? Typically 2003 R2, goes Y upgrade, and that machine runs really, really well. The interesting thing so what's the main resource you run out of on a web server? Memory. How much, on a 4 gig, 32-bit OS machine, how much memory is available to .NET Heap? Any guesses? It comes out about 800 megs. So the memory split in half, 2 gigs for the OS, 2 gigs for system space, right? Or for working space. And there's a switch you can throw, the PAE switch, to say, I want to run the OS on only 1 gig and give 3 gigs over to the line, which I found is a switch that really says, make my server run really slow. So it's not a good switch. It's just the reality is the OS needs more than 1 gig of RAM. It just doesn't work well without it. So, then you throw in IIS, and you throw in the .NET Framework, which takes a non-trivial chunk of memory itself, and your app, and you end up with you're able to use about 800 megs a heap before you have a panic GC, right? Before the garbage collector will slam through. And the important thing with a panic GC is that a panic GC will throw away all cache items too, right? So it's only about 800 megs. So I had a customer who had gotten their site to the point where the worker processor was recycling every 30 minutes. So they were running out of memory, they were hitting the panic GC phase, and if panic GC takes too long, because they had in-process sessions, so all through this memory are these locked blocks that have to be rewritten in the next generation, and after a few seconds, mom calls, right? IIS says, okay, everybody out of the pool, recycle the worker process, right? Which is a way of freeing up memory very quickly. But people literally couldn't finish their shopping carts. It was every 30 minutes. So, you'd put a few things in your cart, and it would go away. How nice, right? That's not a good conversion rate. They'd move on. And they said, can you fix this? Yes, I can. Can you fix it now? Because it takes a few days to figure out, can we go out of process, all those sorts of things. So the fastest thing we could do that would really make a difference is we switched them to 64-bit OS. So we went up to 2008 64, and we put another 4 gigs of RAM in the machine. Now, the first thing that will happen is you'll discover that they compiled any, which means it will try and run the app in 64-bit mode, and it will fail. Because you probably don't have the right database drivers. Compile as x86 so that it runs in 32-bit mode. It can only address 4 gigs of RAM, only. But now you have 8 gigs of RAM, you can set up a couple of app pools with 2 gigs each and give them all of that app, and you go from about 800 megs of available heap to 4 gigs of available heap. And now we went to recycling the worker process about once a day. So the app was still broken, but we could at least make some sales, and meantime now spend the few weeks it was going to take to fix the app properly. So my now favorite configuration for a web server is 64-bit OS, app compiled as 32 bits. Because the only reason you would compile as 64 bits is you need to address more than 4 gigs of RAM for a given app pool. And if you need to do that, what are you doing? I mean, 4 gigs is a lot. 800 is not that much, but 4 gigs is a lot. You should be okay, right? Maybe get another web server. There's better ways. And the reality is, not that 64-bit .NET doesn't work. It does. But testing your app in 64-bit mode is more work, and it doesn't buy you anything. So it's worth just remember to compile. And you'll notice in Studio 2010, they've gotten rid of the default compile any. It now default compiles x86. So we will have fewer problems with that. So that was a question that I had earlier, and I thought I'd just share it. Is this news? Has anybody heard of this? Do you do this? Everybody running 64-bit OS? Is it useful information? Worth the price of admission? Okay, good. Well, I mean, it's another one of, we're talking about the tricks that About.com did. It's another one of those configuration things. There's a debate as to whether, does it actually run faster? And my experience, no. It makes no difference whether it's running on a 64-bit OS or a 32-bit OS, other than it has more memory to play with. The other thing you'll run out of on web servers, really, before you run it, is threads. Threads are really, eventually you run out of worker threads. And that usually is a sign that you've got long-running connections of one kind or another. Typically, you blame it on the database guy. Right? So, slow queries, your fault. I'm going home. Right? That's where we run out of worker threads. But otherwise, you run out. And I mean, in theory, if a web server is really happy, if it's thriving, and the big things for a web server thriving is that the heap is always going to fill up. Every time you run a page, you allocate memory, right? That's just life. And when the page finishes, all that memory is marked as deleted. And that just happens, this is how .NET works. And we just add to the heap, and GCs are running on a regular basis and cleaning that up. And in a happy, healthy server, the heap will hum along at a certain level, 400 or 600 megs, somewhere in there. What messes this up is in-process session. That's what wrecks everything. In-process session is the devil, right? Cache can do it too, but cache can be thrown away in a panic, right? People get a little crazy with the whole caching thing, right? They get the caching hammer and everything's a nail, right? And they're caching everything. And I had this app where literally by the time everything was cached, they were out of memory. They didn't have anything left to run, right? They cached everything. And so we actually cut the number of cached items in half, just stopped caching things that didn't need to. The number of times you have caches where they never get hit. I cache it, and it expires, so we throw it out before anybody ever uses it. So you can go a little nuts at cache, but in-process session is the one that breaks web servers. I wish the default was out of process. We would just default to state server, even if it was running on the same machine, because then it would at least be out of the .NET heap. Question to the back. Sorry? Yep. Yes, there is, and I've never seen it done successfully. Yeah, you can go in and modify the registry entries to control the threads if you want to, but you know what? They're right. I hate to say it. It's just like rewriting garbage collection, right? Yeah, you could do it. Don't. Sorry? The machine config? Yeah. But in the latest version, they've basically taken that away. You don't need to do that anymore. They're doing it themselves. They're doing it now. Really, it's moving towards the virtualization model, and they're being more free-threaded about it. And so it's in there, but you don't need it. Depends on the version, right? If you're still running IIS 6, then yeah, you care about that a lot. But IIS 7.5 doesn't matter. It's changed. Question here. I have, and in fact, early prototypes of the Strangeloop device was running on a reverse proxy. We're now an endpoint, so we don't do that anymore. It works. I mean, it's a technique, and certainly interesting instrumentation. You can see a lot that way. But you know, I wouldn't have no complaints there, and whatever works for you. In the front.
I got a quick question going back to the memory performance. That new support with HTML5 performance stuff, does that work with Ajax?
Yes, and all of this could be done with Ajax, right? It will, the measurement, once you start the nav start, it will capture all of that. So yeah, it knows, and you can just keep back and check the numbers again and check the numbers again. Okay?
What are your thoughts on Azure and web performance and really how that's going to change the way we kind of do apps in the future?
Cloud does not solve scaling for free, okay? What's interesting about Azure is the worker role approach pretty much confines us to scalable techniques, right? They've now taken away the in-process option, right? All of the dumb things we could do, they've just eliminated that. So that helps, but that's only for greenfield, right? I've not seen anybody really migrate an application successfully into the new model. And most cloud work I see these days is just remote virtualization, right? They're, you know, if you're using EC2 and so forth, and no complaints about any of these things, but it's just recognizing if you don't write a scalable app, it's not scalable. It's just now it's remote, and you've launched a bunch of instances that don't work well together. You know, they've certainly, the upside to the cloud approach is learning how to configure an F5 big IP is hard. Hire somebody, by the way. Like, use the F5 guys. It ain't worth it, okay? But setting up load balancing in Azure is easy. So a lot of that network plumbing stuff, that got way easier. But our jobs as developers didn't. You can still write a singleton inside of Azure and completely cripple your ability to scale, right? Microsoft will always give you enough rope to hang yourself with, and it's still there. So you still have to use techniques that will scale, and you need to test. You need to know, actually load it up enough to go across multiple instances. The useful thing about that, of course, is you can use the cloud to load test too, right? It's all together there. So, but I like it. I think it will work. But I think too many people think that the cloud comes in a spray can. It's just if I squirt a little on, it'll be good. And it's not. You really still have to do the right thing. Sorry, did you have a question in the back? Further back? No? Sir, ma'am?
So is there a parallel return on investment argument for when you're working on sites and things that are just internal to your company?
Is there a parallel argument for, is there a reason to performance tune an internal website? Yes. It can equate into numbers when you start adding up, hey, if I can cut an hour off of entering my TPS reports for 1,000 people, like that's real savings. There is the satisfaction angle of that, people will use an app that they like, and fast apps are apps that people like. And we hit this early on in there. It's what is your business metric? Is it search results? Is it conversion, or is it user satisfaction? It's just a tougher number to measure. It's much easier to plug into people's greed when it's like, I'll make you more money, but productivity matters. And so I think you have to do the math of how long, and everything starts with instrumentation. How long are they spending entering their timesheets in a given month? And then the proposal is, we're currently spending on average 35 minutes a month per person entering timesheets. I think I can get it down to 15. And that's this many dollars of work, right? That's, this many months of work when you add up to a large number of people. And that's the thing that happens with software, right? The scale of people is huge. So I do think it's there. You just have to do the math a little differently. Sir?
I can ask that question. I've been doing this for 2 years with medium-sized websites.
Mm-hmm.
And it's a win-win. It's faster for the person using it.
Yep.
And it's less resource for you.
Yes.
All right? About.com, well, I actually use the work for.
Mm-hmm.
I'm amazed they actually did it because they're crazy. But
Yep. Put the headers on.
Yeah, told it that it expires, so the person wouldn't ask for it again.
Yeah.
Which means they spent less time getting stuff for people. The people were faster. This is the ultimate win-win.
Yeah.
This is an amazing thing to do.
And it,
I cannot tell you enough. It matters the most.
and I'm totally with you. It's especially the configuration settings. Like that is just low-hanging fruit. Go turn the stuff on.
F5 wants it all.
Yeah, they do. They absolutely do. Sir.
I support an internet environment with about 400 internal-only websites. Believe me, I get calls. Stuff is slow. Doesn't even have to do with, my server.
But it's still your fault. Yeah, I mean, absolutely, they care, and they'll notice they'll notice for a day or two when things are better. Then they just expect it. Yeah, it just goes away. Yeah.
Again, this is a mutual thing between the developer and the IT person. Those settings have to be on the developer can't do it.
Yeah.
The developer needs to
This is actually ops that does the configuring.
it's a half and half deal.
Yeah, absolutely. Sir. They're about 40 grand a crack. Buy two for redundancy. But compared to, the upside is you'll know in a week how much difference we'll make for you. As opposed, and I'm not trying to sell Strangeloop here. That's not why I'm here. This is where I got my data from. But that's our whole thought. I made a lot of money doing performance tuning, but it takes months. And the upside to appliances, you'll know very quickly. I work for the government. Folks, thanks very much. I'll happily answer more questions, but feel free to get out of your way.